Are you ready to take a deeper dive into the world of asynchronous JavaScript? I have prepared some very interesting advanced techniques of asynchronous JavaScript that will make your code run faster, look nicer, and probably make you proud once your name appears above it on GitHub. Are you interested in learning something like this? I thought so. Let's jump right into it. Greetings, dear friends, fellow programmers, and those aspiring to be. Welcome back to MarkoCodeAcademy. I'm Marko, and today I would like to talk about those upper-mentioned advanced techniques for handling asynchronous JavaScript. Quick disclaimer before we begin our journey here. If you are not familiar with the basics of asynchronous JavaScript, I highly recommend you to go back to my playlists about asynchronous JavaScript, take a browse, go through the entire journey of mastering asynchronous JavaScript, get your updated knowledge ready, and then come back to this video, and that way you will get the absolute most out of it. On the other hand, if you're already a seasoned professional with asynchronous JavaScript, you can just sit back and enjoy the video. Did you ever find yourself handling multiple asynchronous operations at the same time and wondering if there is a better way to handle those? Well, if you did, you're about to be very excited because in this video you will learn basically exactly how to handle that situation. To get the most solid understanding of the underlying concepts that we will need and master today, I will be using a real-life example, let's say real-ish world example, and we will be building a simple weather app that is going to have to ping multiple API endpoints to fetch all the data that it needs in order to do what it's designed to do. Meaning, we will be bothering those API endpoints, then doing some operations on the data we receive, and just displaying it to the end user, which is basically the flow that you will be repeating in most projects you'll ever be building. And when you think about it, this process will include a mixture of parallel and sequential execution of asynchronous tasks in JavaScript. So it will be very interesting to see how everything can be handled in real life. Of course, we will not neglect error handling. We'll cover it as well. Let's head to our favorite IDE and continue from there. And we made it. Here is our example that we will be working with and improving on in this video. So, as I promised, we have 3 API calls that need to be executed in order to fetch all the information we need for our weather application. I think the best way to get started here is to be a bit pessimistic. So right now our code is very glass is half full because we do not have any error handling logic. If anything here goes wrong, we will just be greeted by some blowing up in our application and nothing will be transparent. We'll have no idea what went wrong or where it went wrong, and we do not want that. So the best way to handle this is to wrap everything here into the try-catch statement. And now things look better already. We have some error handling logic in place. It is not the greatest, but it's not bad. So if anything in this try block goes wrong, we will know about it and log it in this part right here inside of the catch block. and our application is not going to be blowing up. Now, this is the initial state of validating our application and making it bulletproof. But still, there is a lot of things that can go wrong. For example, let us take a look at our code here and just imagine what would happen if our, for example, current weather response is null. Well, in that case, we will be returning null as a result of this fetch weather data method, and we will not do the best thing in general. So what we can do is add another line here, which is going to contain a check, and to make sure that our current weather is perfectly fine, not null, not undefined, we will perform a check, and the simplest way to do that is to use this notation right here. If you use exclamation and then the variable, it will be equal to that this variable is equal to null, or that this variable is equal to undefined. So this part right here is identical to this part right here. It is the same exact syntax, but just this right here is way more elegant and basically a syntactic sugar provided by JavaScript for us. So we can remove it and go back to our initial notation. So right now, if current weather is empty, we will throw an error and end up in our catch block, which will log an error, letting us know that something went wrong in the process of fetching weather data. Now, of course, we want to do exactly the same thing for other two API calls because they do deserve some love and preventative checks if they're valid. So this is exactly what we will do. So we will introduce checks for our forecast response and also for our metadata response, checking if they are valid, and if they're not, we will be again throwing an error, exactly the same way as for current weather. Now, when we are done and we have relatively bulletproof code, I want to ask you a question. How do you think this piece of code behaves when it comes to performance? So when we think about it and dissect this method into pieces, we can see that we are executing 3 sequential actions that are blocking JavaScript from executing everything after them. So once we get started with our first fetch statement, we're blocking JavaScript engine from proceeding to all the other lines until this line is done executing. So before we receive the response for our first API call, we cannot proceed to the second API call, meaning that nothing will be happening and we'll be wasting time. Then what we are doing is once that first API call is done, we do exactly the same thing for the second one. And the third one is waiting for the second one to be completely executed. We receive the response for the second one, and then the third one gets started and gets pushed onto our call stack to actually receive the response for the third one. And once the third one is done, we will then return from this method with responses we received from all of these 3 methods. So when we think about it, if we need to know that all 3 of these pieces of data are at our disposal before we can return the result, and we do not care about the order in which we receive these pieces of data, we just know that we want all of them at our disposal. So why don't we make these calls execute in parallel? And that way, significantly improve the performance of our application, right? So what are we going to do with our beloved code to make it execute in parallel? Well, we will be using Promise.all method. To show you how it looks in action, well, here it is. As you can see, our method is completely transformed. Now, let me explain what exactly we did here. So first of all, we have created an array of tasks that we have. So we have still current weather, forecast, and metadata. Then we're awaiting Promise.all, and inside of it, we're pushing all 3 API calls that we want to get executed. And once all of those methods are executed, we will just return them in exactly the same fashion as we did before. And also, it is still wrapped inside of try-catch block. The only difference, and that difference is a downgrade, I have to say, is the fact that we are no longer able to check whether each of our API calls maybe fails to return us a valid response. But on the other hand, we gain so much when it comes to performance. When it comes to Promise.all method, it will do the following. It will push all 3 of these API calls, and all of those 3 API calls will be made, and then this Promise.all method will just wait for the signal that all 3 are done. They will not be executed in the same way as before. So I'm talking about first one is started, the first one is ended. The second one is started, the second one is ended, third one is started, third one is ended. It will be something like first started, second started, third started. And then they all get ended in the order depending on the payload, on the time needed to actually get the response from each of those. So the end times can be reordered, but they all get started immediately practically. So now that we know that our code is well optimized and the performance will be significantly improved, I have another issue that I would like to discuss. So in the Promise.all method, if any of those 3 API calls fails, we will just end up in the catch statement and everything will basically be for nothing, because just a single task of those 3 has failed, and the other 2 may have executed successfully, but the response is going to be for nothing. So we do not maybe want to have that in place. And if we really do have the case where we want to fail the entire execution, if any of those 3 calls fails, well, in that case, Promise.all method is the way to go. But we want to make it a bit different, and we want to take our example because it's imaginary, and we want to make it so that even if some of the tasks fail to fetch the data properly, we still want to be able to use the data that was fetched properly, which makes sense in reality. So to make that happen, we are completely covered by JavaScript. Just instead of all method, we want to use all settled. And we also need to introduce a bit of a different logic when it comes to handling final responses we receive. So let us jump to our IDE. And now I can show you exactly what I meant. So as you can see here, we have our results, they're exactly the same. We have all settled method instead of all. And here we are using results that we received, potentially containing all 3 of our tasks that we had. And then we will iterate through all of them using a for each loop. And basically what we will do, because each result is going to contain 2 parts to it. The first one is status, and the second one is value. Every time you use all settled, you will have that exact scenario. You will have status and the value if everything went well, and you will have status and reason if something went wrong. So we are iterating through all of our tasks and checking whether the status is fulfilled, and if it is fulfilled, then we know that everything went well, and then we can access the response data by using result value property, and if the status is equal to rejected, in that case, you will basically enter this part right here and use result.reason property to display what the problem was. Basically this way, making sure that no matter what happens with your tasks, you're completely covered, you do not care about it, you just check whether everything went well or not and handle the situation properly. Everything else is done for you. And there you have it, my friends. I hope you enjoyed this video because I know it was action-packed and contained a lot of value, because it will allow your application's performance and capabilities to be exactly what you want them to, and for every of those scenarios, the performance is going to be maxed out. It will be the best it can be possibly, and now you are completely informed about what you have at your disposal. So use this information wisely, my friend. And now the ball is on your side of the field. It is time for you to sit and enjoy some time coding some examples, maybe building this weather app in real life, and to do it with actually implementing different promise methods that will allow you to actually use in action everything you learned in this video, because that is the best way for this newly acquired knowledge to stick into your mind and be at your disposal long term, which is probably what you want when it comes to something as useful as this is. And of course, if you struggle with anything, or you would like to mention something that is also advantageous, or maybe something I missed covering, please feel free to let me know in the comment section of this video. I'll do my best to address all the comments within the shortest period of time. Also, if you found this video useful and have enjoyed it, I invite you to subscribe to the channel and turn the notifications on. That way, you will not miss the upcoming lessons, which are going to be as awesome as this one, and we'll be covering a gazillion of different beneficial things that will make you, my friend, an amazing JavaScript developer. So yeah, that's it for this lesson. Stick around, and until the next lesson, goodbye. Happy coding!